Hi, today we continue talk calibration instrumentation device. If you want to do calibration, you should remember some number. Output signal, most time we use 4 to 20 mA, but you should remember 4 mA equal to 0%, 8 mA equal to 25%, 12 mA is 50%, 16 is 75%, 20 mA is 100%. If you do something, calibration, you have to calculate. Calculate the input value with responsible is output value should match, okay? All these linear. So we can use geometry method to figure out, for example, this one, OAE triangle. Similar is OBF triangle. These two triangle is similar triangle. So if you're similar triangles, they have the formula. A to B is A from O to A is A. B is from O to B is A to B equal C to D. Okay, C is A from A to E, D is from B to F. Okay, linear, relative linear, always this one. Okay, this question, okay, is an input 0 to 150 psi. Is range LRV to URV is range span, but if you're 60 psi, how much is output, milliamp? So we can use this one formula to figure out. Is A to B. A is 60 psi, B is 150 psi, equal C to D. C is Y, D is 20 mA. Okay, so its final result should be 8 mA. Question 2. If input 0 to 320 psi, output 4 to 20 mA. If input 75 psi, what's the output? Okay. Output is 4 to 20 m. Input is from 0 to 320. Okay, is A is 75, B is all the 320, C is Y, D is 20. Okay, that's why C equals 3.75 mA. This one is more complicated. Input 25 to 180 psi, output 4 to 20 mA. Input if 95 psi, what's the output? You should have this one's A, here's B, there's C, there's D. Is A from 25 to 95 psi. So A should be 95 minus 25 equals 70 psi. Its B should be from 25 go to the 180 psi. So B equal 180 minus 25 equal 155 psi. C from we calculate C. Okay, D is 20 mA minus 4 psi is 16 psi. So if you use this formula, we can go to C 7.23. 7.23 just here, but we should plus 4 mA. So it's 720 psi equal 11.23 mA. Also, we can use, before we can use this geometric is calculate, but we can use the analytic geometry to figure out. For example, here's x0, y0, b x1, y1. We can use y1 equal mx1 plus b. First, we got a slope is m. M here is slope equal y1 minus y0 divided by x1 minus x0. So then we should got b. B equal y1 equal. If you got this MA, your enter your MA is this one, y1, x1, which number go inside, you can got B. After that, you can got this formulation. Okay, you can got y, 1. Okay. For example, if an input range 30 minus 90, 30 is x0, 90 is the x1. Output range is 4 to 20. 4 is y0, 20 is y1. So we use this x0 equals 30, y0 equals 4. Okay. For example, if the input range is 30 to 90 psi, output range is 4 to 20 mi. So 30 is x0, 90 is x1, 4 is y0, 20 is 1, y1. So it's x0, y0, x1, y1 is m. First of all, if question for the input 50 psi, output should be what? So like this. First we got m equal y1 minus y0 divided x1 minus x0. This is got m is 0.267. Okay. After that, we use formula. Yeah, we use formula got the b equal minus 4.03. Then we create this formulation y equal 0.267 times x minus 0.3. Then we put the input x 50 psi. We got y equal 9.32 ma. Okay, these two methods. It doesn't matter which method you use, but you have to think in your mind to check the result. For example, if your calculation is the final result 9.32, but you don't know it's true, maybe your math is wrong, but you should think about in your mind. This 3 to 90 is from 0 to 100, so 50% should be 60. So 60 is 50. 60 is 50%. 50% is 12 ma. Is 50 is less than 60, so it's 9.32. The next is 12 ma. So that is okay. Yeah, you can definitely you think it's okay. Okay. Now we talk of 5-point calibration. If 5-point calibration just for analog instrumentation device. Is analog device. Here just showed zero adjustment, span adjustment. This all this together is look this sensor, is security, filter security, is amplifier, is divider, is come out is 4 to 20 MA. Okay, how to do this 5-point calibration. First, you show the connection, like this drawing connection. First, your connection, everything is 24 volts, is current, is voltage, voltmeter in here, and 250 ohm in here. Okay, then first give your zero adjustment. You send to LRV press, go here. For example, maybe you send LRV is 50 PSA. You just send 50 PSA. Then make sure it's stable. Then you just zero screw adjustment. Make sure there is multimeter is reach to the 4 MA. After that, if for the 4 MA, you give the high pressure is for example is 200 PSI. Then you spend your screw, your adjustment span screw. Make sure here is the multimeter is 20 MA. After that, you go back to the zero. You check. If it's not good, you continue with the span. You check first the is 50 PSI. Then go to the 25% PSI or 50 PSI. Yeah, is 0%. Then go to the 25%. You check this the multimeter. Then go to the 50%. You check the multimeter. You want 75%. You check multimeter. Then go to the 100%. You check multimeter. Should be 4 MA or is 20 MA. So you first check 0% is 4 MA. 25% is 8 MA. Is 50% is 12 MA. Your 75% should be 16 MA. If your 100% should be is 20 MA. If you're not good, you just start this one from zero, your zero screw adjustment, span screw adjustment, like this way. Yeah, like 0%, 25%, 50%, 75%, 100%. This often referred to as 5-point calibration. During a 5-point calibration exercise, both upscale, go up, increase, then go down, decrease. Test should be done to determine the repeatedly on the history of the particular instrumentation. Okay? This is smart transmitter calibration. The smart transmitter calibration completely different analog transmitter. You should do trim adjustment. The smart transmitter calibration we call the trim. Okay, first we have zero trim, then is output trim. Okay, zero sensor trim, sensor trim, first sensor trim, trimming the digital circuit of the input analog to digital converter. Output trim, also called current loop trim, trimming the output digital to analog converter. This first to sensor trim. Sensor trim look like all the same thing, yeah. Just hook up the 475 is how to communicate. Go to the transmitter, okay. Then apply the low range value stimulator to the interpretation. Wait for the stabilizer. Then execute the no sensor trim function. You do ignore the no sensor trim function. Then apply the up range value stimulator the instrumentation. Wait for it to stabilize. Execute the high sensor trim function. Okay. This is called sensor trim. First we do sensor trim. This one. After that we do output trim. Is a current loop trim. Then we do arrange in here. Okay. Output trim. The input value for this test is the mm. Just the output trim, just make sure his 4 to 20 MA is working. Okay. It's the output value is obtained using a precision mini amp to measure the resultant current. First, you don't connection any. You don't need to give the source, pressure source, everything. You don't connection everything. Just execute the no output trim test function. Measure the output signal with a precision mini amp. Noting the value after its stabilizing. Okay. Enter his measure current value. The first of 4 MA. Okay. Then you measure the output. Here it should be 4 MA. Here always should make sure his is 4 MA, 20 MA, 8 MA, 60 MA. You make sure here it's always okay. It's 4 MA in here. Then enter this measure current value when prompted by the instrumentation. Execute the high output trim test function. This here is a menu. Menu have no output trim. It's a high output trim. Is the we have output trim menu. Then go to the output trim menu. You can find this one. Okay. Measure the output signal with a precision mini amp. Noting the value after it stabilizing is 20 MA. Enter this measure current value when prompted by the instrumentation. Okay. This is called output trim. This is called sensor trim. First is the sensor trim, then is output trim. After that, calibrate the error between the digital M value produced by the transmitter and the analog MA value measured by the current meter. The desired accurate for this test should also reflect the manufacturer accuracy specification. If a test does not pass, then follow the manufacturer recommend produce for trimming the output section. If you finish the output trim, sensor trim, actually you should, for example, if your connection PLC, you should PLC analog model, you should match there. Yeah, you should calibration is match this one. If you use here, use 4 to 20 MA, in the PLC is analog model, you should have 4 to 20 MA. This calibration configuration. Okay. It's one thing, some transmitter, press transmitter, we have 0 trim. Sometimes we do 0 trim. 0 trim is a single point adjustment. It's useful for compensation for mounting position effect and is most effective when performing with the transmitter installed in its final mounting position. Sometimes if you want to check, you first you do zero trim. Zero trim should not be used in place of sense trim over the full sense range. If you error too much, you can't do zero trim. Okay, zero trim. How to do zero trim? Just two sides, high sides, low sides, to open the atmosphere. Then you push the button, you go to the zero trim, you check the zero trim. Okay. When performing the zero trim, make sure the equalizer value is open and all weight are filled to the correct level. Okay. Before in the foundation feedback, we talk zero trim how to do. Yeah, how to connection, how to do equalize the value, wall, how to open, close. Okay. Most device input and output signal is linear relationship, but except the DP-cell flow transmitter. Is a flow transmitter, different pressure flow transmitter. Is not linear. It's the square root extract. It has a square root extract in the analog device. Is a different pressure transmitter in the classical analog device. It has a square root extract. Is a device, but in the smart device, smart instrumentation transmitter, you don't use this extra device. He has chips. You can check in the hard communication. Hard communicator, he's asked if your square root, you need square root. If you do different pressure flow transmitter, you should mark the square root. Okay. Is flow equal this one? Is different. P1 minus P2 is different pressure transmitter. Okay, times the constant. This is called square root extract. So this is not linear. So you can't use linear function, but you can use this function. Or in the transmitter inside, just if you choose square root, he just automatic figure out everything. Okay, don't worry this one. Okay, you just make sure you know if you have flow different pressure transmitter, you should have square root extract. Okay, that's it. All this calibration information. Okay, that's it. Thank you very much.